Okay, thank you everyone. So let me introduce our panelists. So we've got Andy Cruz, who's the Vice President and Business Development of Homo Energy. Everybody knows the product Homo, and I'll let him talk a little bit about this. But for nearly 30 years, Andy has been involved in international marketing, sales development of certification standard and public policy. And as co-founder of a startup cleanup tech company in Arizona, he built Southwest Wind Power into an international recognized brand within clean energy industry. And I'll make it short. And Dr. Ram Kumar Krishnan, so Chief Technical Officer of Fluidic Energy. Ram Kumar is the Chief Technical Officer of Fluidic Energy, the first and the only company to commercialize rechargeable metal air battery technology, long known as the least expensive way to store energy from an electron. So I'll keep it short. And then we've got Alexandra Goodson from SAFT, sales manager of the energy storage system, has been working in the electrical power industry. Her focus started with wind power transformers, and since then she has been working on battery energy storage integration and field implementation for the last 4 years. And Herbert Crowther, sorry about this, tongue twister for me French here. So president of Megajoule Storage. So Herb, co-founder of Megajoule Storage, based in Cleveland, Ohio, to commercialize asymmetric capacitor technology for stationary energy storage and applications. And we've got Nicolas Seguin from Tuglik that was just presented before. So all of you, thank you for being on the panel. Maybe just a quick turnaround of what you do. Alexandra, at SAFT, you commercialize the SAFT battery, which is lithium-ion battery.
Yes, for our energy storage solutions, we're working with a lithium-ion nickel, cobalt, aluminum technology. SAFT has been around for almost 100 years. We'll have our birthday, the 100th anniversary in 2018. In addition to the energy storage markets, we service aviation, telecom, some military and DoD applications. Currently, to date, we have over 70 megawatts of energy storage projects that have been deployed worldwide. We service the storage market out of Jacksonville, Florida, and Bordeaux, France, are the two manufacturing facilities for storage. So we're certainly have a high profile in some of the microgrid, kind of off-grid applications. We've had some good success stories in those markets, so I'm sure we'll cover those as we go through the question.
What about lithium-ion? It's recent compared. SAF has a long history on energy storage, but lithium-ion is fairly new. Tell us about that and how your company is faring and how much you're installing these days.
SAF started with their focus with nickel-cadmium batteries. In the early 90s, we started manufacturing what we call a large format lithium-ion cell. So it's the size of a tennis can or wine bottle, depending on what your activities of choice are. It's different than the 18650s that you'll see on the market, but we have been working with it for over 20 years now. So it is a new technology, but we certainly have a lot of experience. And that's what the 70 megawatts have been deployed with, is our large format lithium-ion cell.
Okay, very good. And Herb?
Herb Crowther from Megajoule Energy Storage, early stage company bringing bipolar lead-acid batteries to market, and those are commercially available today, and bipolar lead-carbon capacitors that have 10 times the life of any lead-acid battery, which is still at the lab stage, but very promising. And we developed a package solution for the oil and gas industry for a company that has water treatment systems for off-grid remote sites that need 3 kilowatts 24 hours a day. And so we developed kind of a platform of containerized systems that use PV, wind turbines, batteries, and gensets in whatever configuration is best for the site operator and whatever their metric is, if they, whether they want a lower initial cost or a lower levelized cost, it's a different system. And this solution seems to be a good fit for junior mines or after closure or for secondary loads in the mining industry, but it's also a turnkey solution for telecom towers, village power islands, and so this is an order of magnitude smaller than what most of the systems that have been talked about today, but these small systems that are off grid and have a lot of logistics cost and small deliveries, our competition is running gensets, diesel gensets 24 hours a day, and that's pretty easy to beat with a little bit of renewable energy, and so that's the platform that we've developed.
Okay, thank you. So, I mean, we go from one technology to another, so we're actually addressing the first question just by going through the panelists here. But Ram Kumar.
Good evening, everybody. Ram Krishnan from Fluidic Energy. As the moderator introduced, we're a rechargeable metal battery company. Essentially, we've commercialized a rechargeable zinc here. Most of you know there are over 2 billion batteries that are primary alkaline zinc-based batteries that are sold even today. And the main reason for those batteries to be zinc-based or very, very low cost. Zinc is at $3 a kilowatt hour. So that's really what we've taken in the last 4 years is commercialize the technology to make it rechargeable. By the end of the year, we'll have over 1,000 installations, mostly focused in several tens of kilowatt hour kind of applications, telecom, rural electrification, being the two areas that currently we're focused, but we're also partnering with Caterpillar to provide large microgrid application storage, primarily focused on load shifting and long duration applications.
Okay. Andy, and you've got the product Homer that is perfectly suitable for analyzing mining projects with renewables and energy storage.
Correct. So my company, Homo Energy, it's a software company, and its fundamental design is to do what we call microgrid optimization. So we're kind of the first stop. If you're going to build a microgrid, you got an existing diesel on site. We basically will look at the solar resource, the wind resource, biomass. We have a whole plethora of technologies within the software. And so we're looking at the resource, we're looking at the technology, then we look at the load profiles of the load, and then we tell you what's the lowest cost of energy you can get. So that'll result in an output of how many wind turbines or how many megawatts of solar panels or how large your batteries should be in that particular project. So it's all about design and optimization on cost or on CO2 if you have a preference which way to go.
And Nicolas, from the point of view of the user, and from the mining user and also from the IPP, too many technologies, or how do you handle deciding what is best for the mining?
We do demonstration projects like the one we're doing at Raglan. So I guess at this stage, exactly, it's really a matter of being actively listening on the market. The technology changes so fast. Just as an example, what we bought when we gave the PO for some of the technology we presented earlier, about a year and a half after, we look at what's available on the market, and the offer has significantly changed. So it's really important for us to be actively listening what's on the market. And Michel, if you allow me, I'll just tell what Tuglik mission is a bit. So really we are, the niche market we're trying to look at is diversifying away from diesel, all the microgrids, and mostly mining clients. I've worked for Glencore for 8 years looking at the energy strategy. I was happy to hear that the nuclear reactors are still looked at. When we looked at it in 2008, it was 11 years of permitting, so definitely there is a lack of legal framework around this. But moving away the diesel from the mine, that's really what Tuglik does. And we have the renewable side, and we also have the natural gas side, where we propose LNG solutions all the way up to off-pipe market, because we think that natural gas is cleaner than diesel and HFO, and it's a transition gas, a transition period until the time renewable can fully replace or can become a base load generation. Yeah, thank you, Michel.
Okay, no, that's good. The batteries is very, very broad, and we just have an example here with 3 different technologies, and there's more like the flywheels and for different purposes. But what innovations, what are the latest technologies that would be applicable for mining specifically? And aside from your product, just add more.
I think the last speaker pointed out very well. I think no single solution fits every need. Even in the mining case, you've got short durations where you have to actually manage a frequency or manage actually burst of power, where capacitors or even flywheels make sense. For 1 hour type applications, lithium ion seem to be actually quite good for power capability, but really for longer durations where you can actually shift the load, need for low cost like zinc here is coming up.
Any more comments on this?
I would say it really depends. It is exactly that. Is this does the mine need it just for a short-term burst? Does it need it for a long-term storage? And really, there's going to be depending on how much renewables you want, penetration you want on the whole system. The more penetration that you have, the greater percentage, chances are the larger the battery is going to need to be. So it really is, it depends, it's all over the place there, so.
Yeah.
Add something.
Okay.
And maybe if you look at it on a different angle, what the new technologies or new development allows on the storage side is the higher density of energy, which at some point, in terms of storage of energy, it just takes more space. But if you look at on a different angle, we're talking about electrification of vehicles. So if you have a more dense product, you can maybe fit enough battery to match the duty cycles or a regular shift of a mining operator that goes underground and do not have access to electricity for 8 hours. At the moment, we still need range extenders such as hydrogen fuel cells. But if the technology or allows for denser battery and we can fit these, well, you have electrification of underground vehicles, then you reduce your mine ventilations, then it's a different approach to displacing diesel, but at the end you'll be a greener mine. So it's kind of.
Yes, so that's good. So in the previous presentation, I showed 3 different use cases for storages, which would trigger different requirement for the technology. Nicolas points out, there's more than just the renewable, because electrification of transport would trigger yet different technologies that are suitable for this. And Herb, his own technology, which is smaller scale, but would fit on very specific requirements on a mine. And maybe you can touch on that.
Well, so there's a difference. There's a lot of investment around the globe in developing energy storage technologies, whether it's lithium ion or zinc air or the flow batteries. And in the long run, I think a lot of these technologies will find their own niche, their own sweet spot. And whether it's the scale or the ambient temperature that they operate in, or the maintenance, or the weight, or the size. There are a lot of different parameters for the range of energy storage applications. And there's so much investment that a lot of these solutions are getting beyond the prototypes, and now they're demonstrating in the field, and they have to be in the field for a certain amount of time before the funding sources view them as really risk-free. But we're living in an era where we're going to see the cost per kilowatt hour and the cost per kilowatt make a bigger drop than we've seen for a very long time. And that's been the barrier to widespread adoption of energy storage. Lead acid battery has been a technical solution for a very long time, but now we've got, and it still is, but we have a lot of other alternatives coming to market
So let's
now.
jump to that, the economics. You know, that has been a roadblock, like you just mentioned, the cost of storage, where it's going, and whether its current economic. Maybe Alexandra?
I never get asked that at these shows. No, so I mean, certainly we're seeing a price per kilowatt hour decrease. Every year we've seen a cost reduction, and whether it's because we've been scaling up the factory, so we have economies of scale. Also with enhancements, we're providing a more energy dense or a more power dense cell, depending on whether it's our energy or a power cell. So we're able to, you know, 2 years ago we were offering, I want to say it was 1.6 megawatts worth of power in our 20-foot container, and now we're at 2.2 megawatts of power in the 20-foot container. So it's not just the technology that's being seeing reductions in cost, it's the whole system level that we're able to do. But that is, it's a driver right now.
Well, to add on to that, the other part of the cost picture is the power electronics, and it's one thing for the cells to get cheaper, but really the customer's looking at the total cost of acquiring and the total cost of operating, and there's a lot of activity in driving down the cost of the power electronics, and that's going to have an effect on the affordability for whatever the application is.
So I agree. If I can make one comment, we've certainly seen power electronics pricing going down. I would beg to differ, and I think the big driver is going to be on the battery side. I think the power electronics technology is much more mature. Pricing is probably stabilized a little more, and the batteries aren't quite there yet. And on a lot of these projects, particularly on the lithium-ion side, when you're looking at 30 minutes or an hour or 2 hours worth of duration, your big cost driver is the battery. When you look at you break down your project, you've got a 2-hour battery, the power electronics is going to play a much smaller role in the overall system cost.
Ramkumar?
Yeah, I think levelized cost, as you all know, is going to be the driver. So system level cost is a pretty big component, and even in markets that we go today in telecom, for example, even though they use lead acid batteries in a major way, the initial cost of the battery is one thing, but then what is the amount of cooling needed to maintain the battery? Can it actually survive at low states of charge if for whatever reason the outage is very long, and what's the cycle life impact on that? So I think it's a combination of multiple factors, and that's where we differentiate in that space, particularly because we don't need cooling, or we can operate up to 50 C without actually any impact on lifetime. And so those are some other factors apart from what the initial cost of the battery is. Theft is another big component. Mining is also another area where theft is a big problem. And what is the value of these products? Can you actually embed electronics and controls? Today in our battery, they can't steal our batteries because there's no value, and they can't actually use the battery without the controls. And so that's where controls and monitoring and system level integration can actually influence what the cost of the system is.
Okay. Andy, how do you see how can you get the value of battery on a grid when you use Homer? How do you quantify that?
Well, it's just a matter of modeling it, and this is one of the challenges. We don't always know the cost of the batteries, and so we try to connect through our software our designers, the system designers, with the manufacturer directly, so they can provide the information up to date, because it is changing. Early this morning we heard someone talk at, I think the United States had something like 63 megawatts of storage. I'm not sure if that was accurate or not, but in the United States, 63 megawatts of storage currently, large scale, and it's going to grow by 14 times or 15 times or something in the next year. And if that's the case, there's no question that the price is going to continue to go down. We're going to see that. So we're going to see the innovations going from 1.6 megawatts to 2.2 megawatts. Is that right? We're going to see that happen. And so for us, it's just a matter of just plugging it in then and really just adjusting the price, and that results in your levelized cost of energy improvements. So we'll see. It's not Moore's law batteries, but it's we're going to see some significant breakthroughs very very soon.
So Nicola, obviously you know the prices you want to see.
Yeah.
What are the targets? What are the threshold you're willing to pay to enable your grid?
Well, at the moment, what we do is we develop always for 3 projects, 2 scenarios in parallel. One where we get as much renewable as we can without having the storage. And the second is where we would have more renewable, but we add storage. We have to overcome the fact that the client thinks that the more renewable, the cheaper the dollar per kilowatt hour is going to be. Yes, you have some synergies, economies of scale because you rent the crane for more kilowatt that you install and stuff, but you offset those savings by the fact that you add storage. But if you look at it on an absolute dollar savings at the end of the year, let's say you save $1 million with this amount of renewable. Well, if you double this amount, you're not going to save $2 million. Maybe the second portion of the project will only save $800,000, but on a global scale, you'll save $1.8 million instead of $1 per year. So yes, the last tranche of electricity might be a bit more expensive or slightly the same, but it might be interesting because you save more at the end of the day, even if you pay a little bit more. So those are always the 2 scenarios we're looking at, and at the end of the day, we look with the client. Of course, you induce a bit of risk if you have more renewable and storage in it, but
Okay.
If I could add to that, we actually use the Homer software as well, and it's really good at going deep on those scenarios and looking at where the inflection points are and being able to see, well, what are the priorities for the site operator or other stakeholders, and being able to give them options that are really fairly robust in terms of being able to deliver the performance of the configuration that fits for them.
I mean, today the diesel fuel prices are at the low end at around 25 cents, including the maintenance costs and all that. So really, and PV prices are already dropping below 10 cents a kilowatt hour. So if you can keep the battery wear cost around 10 cents a kilowatt hour, which is really we've been working towards that can really change the whole economics, because now all of a sudden, even at the price at $50 a barrel, you can actually make renewable penetration a real reality.
So just to say numbers, remember to see prices around 30 cents a kilowatt hour, and now systematically we're going lower than that. You mentioned a target of 10. Certainly it depends on the technology, depends on the contracting, depends on how much time you're going to amortize it. But definitely we're going to a pricing level that is of great interest for the projects upcoming. And so for the roadblock of pricing, it looks like we're going to get through it sooner than later. 2 other roadblocks, and I'll just mention, it's safety and reliability. Is this technology safe? I mean, if you look at track record over the last 20 years, every one of the big companies had batteries that blew up or took fires or things like that. And there's also the reliability. Your projects for wind and solar now is 20 years and more. You can ask for 25 years now out of a wind turbine and a solar farm. But what about storage? Can we get that sense of safety and reliability?
Yeah, I think I can comment especially on the safety side, because we focus a lot on that. Metal layer battery is one of the big advantages that there's no thermal runaway possible. It's an aqueous battery. So there are other batteries that are coming up where aqueous batteries are inherently very, very safe from a thermal runaway standpoint. So we don't need any kind of fire suppressants and other active ways of suppressing it. The other piece, in terms of reliability, I think modularity and scalability is really the name of the game today. If you look at almost every battery company, they're already integrating capabilities to allow for modular approach where one component doesn't bring down the entire system. That's a similar approach we've taken. In fact, in some of our systems, you can actually take one cell out and still actually the module will perform. You can mix and match old cells. Those are all some of the key functionalities that will actually determine the reliability of the system.
Alexandra, well, I'll comment. I know about some of your products where you can warranty the battery for 10, 15 years, and then you have also software that can predict the time of the battery. Maybe comments on this, it's kind of innovative.
Yeah, absolutely. So the chemistry itself has a calendar or shelf life of beyond 20 years, which is unique to the NCA chemistry that we're working with. So obviously, the more detailed information we have on the cycle profile is going to drive what sort of warranty or guarantee we can provide. But we have provided warranties beyond 20 years for certain projects. Certainly, in addition to warranty, we have availability requirements or performance guarantee requirements depending on the application. And we're able to provide those because of a software. It's MATLAB Simulink modeling software that we use. I'm not the modeling guru, but that was when we started working with the lithium ion in the early 90s. We started evolving this software, and it doesn't just look at the cell or the module performance. It's on a whole system level. So we're looking at your increased impedance over the years as the battery is being used, the cooling efficiency, how we've designed the HVAC inside. And so we're able to put in the usage profile, whether we're smoothing PV or we're reducing diesel consumption. We can put in those profiles into the model, and it'll accurately give us the degradation of the system on an annual basis. It degrades quicker as the battery ages. We've had this software validated by third-party engineers that were hired by some of the financial institutions that finance some of our projects. So it's been vetted and validated from a third-party perspective as well.
Well, what about the safety?
So safety is obviously a top priority, and it's a very big concern. You mentioned some of the other incidents that had happened. Without going into specifics, so let's start at the manufacturing process. You start on the manufacturing side. You want to have high quality tests all along the way. SAFT's cell manufacturing process has no human contact until the cell is completely welded and tested. So you want to make sure that your manufacturing process is top of the line. And then on top of that, you have to plan for an event. You manufacture, you design it, such that it won't occur, and then you plan for it to occur. So we have safety parameters on the cell level, the way that it's designed to vent in case there is a thermal runaway, because it's a risk. We have safety levels on the module side. We have a fire suppression system that's the Siemens system that's integrated into the container. So you have to plan for an event. You certainly don't want it to occur, but safety is a concern. Some of the issues that happened, like in Hawaii and other locations, didn't even have a fire suppression system in the enclosure where the batteries were. I mean, come on.
Yeah.
And surprisingly, there are products that are being sold on the system level that still don't have fire suppression systems. So something as simple as that.
Good engineering is important.
It is, and
Okay.
that's SAFT handles it all. We're kind of like a vertically integrated storage company, if you want to call that. So from the cell manufacturing up through the containerization, it's all done for US in the Jacksonville factory. So we have system level engineers, within SAFT that are designing the whole system,
Okay.
and safety is a big part of that.
So, I mean, it goes, the points I was making before is when we order energy storage, that has to be in the specifications. So you want reliability, you want safety, you want performance. And to ensure this, you've got to, on the contracting side, or on the specification side, you've got to put those requirements, because the storage vendors can meet those requirements if you tell them, because it's always additional costs if you ask for more. So how does energy storage enable high penetration?
Well,
Nicolas,
the three use cases that we're looking at, so
yes.
really it's really the three use cases that we looked at. So for smoothing the power curve, that's going to help. It's all about operability and about the predictability, well, mostly operability that'll help. So grid stability, frequency regulation, voltage regulations, and backup power, if I can sum it up quickly.
Okay.
Well, and add to
one
that,
more word?
load following, especially with, with diesel gen sets, you can get, you can avoid low part load operation, and you can provide additional power. You can size the gen sets for average instead of peak, and When you add in the renewable energy and you can smooth out the intermittency, it adds even more value.
Okay. Any questions from the audience? Yes.
One of the technologies that we're looking at is variable speed genset. And we're looking at that as a way to reduce the size of the energy storage system that's required to reduce the overall capital cost. I'm just wondering if you have a comment on variable speed genset technology.
We haven't looked at this technology, so maybe you can let us know a bit more. But so it would impact the size of the storage because you can. No, we haven't looked at this technology on our side.
Okay. I don't sell that technology, so I can give an overview of why we're looking at it. But it's for smaller hybrid systems at 10 megawatts. And its main competitive advantage is that it can run from 100% load down to near 0% load at very high efficiency. And it can react very fast. It's got a very good step response. So for high penetration renewables, you may not need as much storage because you've got a spin reserve.
Right. Yeah, well, maybe what I can comment on is one of the burden or one of the challenge is to not operate the gensets within where they clutch and unclutch the turbo with, let's say, around 65% of the load, and then they lose efficiency. So if you have an engine that do not have any limitations for the whole spectrum of operating from 0% to 100%, that's definitely a big constraint that you remove out of the system design. Yeah.
The only thing I'd add to that is batteries do a lot better job of load following than a genset. I mean, our model is to try to have the generator either be on or off, and let the battery do the rest, because that's going to give you a lot more life. You know, at least in the small systems, you burn up a lot of generators, especially if you're running them all the time when you could have been using a battery.
Any other questions?
Yeah, I guess I have the box. Hi, Nicolas, you talked about the storage system under harsh climate conditions and in particular very, very cold. I was wondering if the panel could talk about how different storage technologies can handle hot and dry or hot and humid climates, and how performances can be affected because of those harsh climate conditions. Thank you.
So I'll jump on this one. Our systems are in an integrated, an ISO high cube shipping container. So part of the design of that container is extra insulation within the walls, false flooring and insulation underneath. We do have a cold weather package. We just commissioned a system up in Northwest Territories, and it had to be designed to operate down to -50°C ambient conditions. So that was a couple extra levels of insulation. Can't remember the details, but we had to separate like a heating coil. We were taking some of the heat from the diesel genset to use to heat up the container. But we designed the full system to make sure that it can handle the ambient conditions. And then same on the desert side. We have a few systems that are in the California desert, and it's just a different level. It's still the same kind of insulation, slightly different HVAC and cooling requirements. But the technology, we're maintaining the internal temperature to make sure that it's within the operating requirements.
Yeah, I'll add that, you know, there are different technologies for depending on what the temperature range you want to operate. Especially on the lithium side, titanates are very well known to operate as high as even 55°C. You know, our batteries, almost all of our battery installations are all outdoors. And in places like in Indonesia, Latin America, we're going to Pakistan and other areas as well. So again, that's one of the attributes that we bring along, that, you know, we don't have the same type of degradation that's commonly seen in, you know, batteries like lead acid, for example.
Right. Okay. Any other questions? Yes?
In the last couple of years, solar panel has become a commodity, which is really driving the whole market to a nuclear state. Do you think that battery storage solution will be becoming a commodity at a certain stage? Or if it is, what does it take to get this?
So I think for certain applications, you'll see batteries being treated more like a commodity. If you just need a large, dumb battery system to just follow like P and Q signals, you know, 1 cycle a day, something that's really simple, it'll probably be more like a commodity. I think these mining applications and these off-grid applications, you need an intelligent battery system and one that can respond within certain speeds, and it takes a lot more integration on the control side and with the integrator. So I don't think for those kind of projects the battery is going to be treated like a commodity. There's too much system level engineering and integration that needs to be done for these kind of applications.
Yeah, I would certainly echo that same sentiment. You know, Rick from Caterpillar in the morning gave a very good speech about integration. I think that's really the key, in that you've got very, very different type of technologies that go into providing both energy storage as well as energy generation. And so smart integration of these components and efficient use of this and building actually intelligence into the batteries is really the way to go.
Now, for the microgrid projects that we've been involved in, our controls engineer, let's say, works directly with the microgrid controller, who's ever providing kind of the system level control at these off-grid sites. So there's a lot of interaction. We're embedding some of our algorithms into their, I call it a site controller. So you can't have just a battery system, I give it to you and you go with it for these kind of applications. There's a lot of integration behind the scenes that goes on. So.
Okay, just one last question, and then we'll wrap it up. Some?
I think we're going to have to, sorry, Michel.
We have to stop? Okay.
We're going to have to wrap it up, but merci beaucoup, Michel.
Okay.